Let's create AI traffic system using Python. We import FastAPI components for the web framework and form handling, HTML response, and Jinja2 Templates for rendering web pages, Random Forest Classifier as our machine learning model for traffic congestion prediction, and NumPy for numerical data processing. We initialize the FastAPI application with a descriptive title and configure Jinja to load HTML templates from the templates directory. We define training samples where each row contains 4 features: vehicle count, emergency vehicle count, pedestrian count, and peak hour status, representing different traffic intersection conditions. These are the target labels representing congestion severity levels, where each number corresponds to a category such as low, medium, high, or critical traffic congestion. We initialize a random forest classifier with 10 decision trees and train it on the traffic dataset so it can predict congestion levels from incoming traffic conditions. We define a helper function that contains the machine learning inference logic and returns a structured traffic management recommendation. We convert the peak hour Boolean value into a numeric flag and pass all traffic features into the trained model to obtain the predicted congestion class. We define a mapping dictionary that converts each predicted congestion class into a human-readable traffic status, severity level, and recommended signal timing duration. We retrieve the mapped values for the predicted class and return them as a structured dictionary along with a custom urgency score that gives extra weight to emergency vehicle presence. This async get route serves the homepage and renders the template with empty prediction data, so the interface loads cleanly before any analysis is performed. This async post route receives traffic information submitted through the form, including vehicle count, emergency vehicle count, pedestrian count, and peak hour status. We convert the peak hour string value into a Boolean and pass all traffic parameters into the inference function to generate the AI-powered traffic recommendation. We package the submitted form values into a dictionary and render the homepage template again, passing both the prediction result and the original inputs so the user can view the recommendation alongside their submitted data. Now here is our index.html, where I have designed the all-user interface. If you'd like access to this code, just send me a message on our Discord server.